quickly, we are going to discuss piecewise functions. Yes, from the name piecewise, you can actually tell the kind of function we are dealing with here. Yes, we are dealing with functions of varieties of functions at intervals. So I'll give you an example, then I'll solve examples. I'll solve as many examples as I can. That'll be helping you probably to solving piecewise functions on your own. Trust me, after the class, believe me or not, you are going to solve piecewise function yourself. Yes, and believe me, just have that belief in yourself that after this class, I must be able to solve piecewise function myself. Let's see examples. Yes, if we have a function f of x, 5x plus 3 at x less than 2, 2x squared plus 5 at 2 less than or equal to x less than 4. And we have x cubed minus 5x plus 3 at x greater than or equal to 4. Solution. I will now be predicting questions. So just follow me as I predict my questions. Are you ready? So I'll predict as many questions as I can in this topic here, in this example. So I'll just predict questions. As I am predicting the questions, we solve the question straightforward. So let's have a question. Let me predict one question. Now, shall we find the limit of x approaches 2 from the left? Yes, this is pronounced or read as limit as s approaches 2 from the left. You can see the negative. Take note of all those signs. This is read limit of s approaches 2 from the left. If it was positive now, it will read limit of s approaches 2 from the right. Are you with me now? So if we are going to find the limit of s approaches 2 from the left now, how do we find that one? Now remember, 2 from the left, we are coming from this side here, isn't it? This is 2 from the left. All the value from the left here, we can have 1.5 in this part, we can have 1.9, we can have them. You understand now? So one thing is, that means a 2 from the left will exist in this part, in this region here, isn't it? So shall we find the limit of x approaches 2 from the left? So the limit of x approaches 2 from the left. Remember, this value indicates x being less than 2. Yes, in one word here, s is approaching 2 from the left, isn't it? Numbers less than 2 include 1.9, just like I have mentioned here now. Include 1.5. So in this case now, x is approaching 2 from the left. You understand? So we are going to consider the function, which is a 5x plus 3, isn't it? And we insert 2. Anywhere we see x, insert 2 there. We have 5 open bracket 2 plus 3, which gives me 10 plus 3, and which is 13 in question there. I hope you understand what I'm doing. S approaches 2 from the left. Values approaching 2 from the left include 1, include 1.5, 1.30, 1.99, you understand, 1.8. So the range of values that approaches x from the left is this value here, is from this range here. That's for that one. What if we are asked to find the limit where x approaches 2 from the right of that same function? You understand now? Limit where x approaches 2 from the right. You understand now? So automatically this one is going beyond 2. Sorry, this one is going, remember this one is x less than 2. So this one can only cover values approaching 2 from the left. But look at this. There's an interval here. 2 less than or equal to x less than 4. Number less than or equal to 2 less than. Number, if 2 is less than or equal to x, then x is greater or equal to 2. So number greater than or equal to 2, we have 2 point something, 2 point something. So that means x is approaching 2 from the right here. So the function of that one, since we are asked to find the limit where s approaches 2 from the right, then we consider this function here, which is a 2x squared plus 5. And inserting 2 there gives you 2 into 2 squared plus 5. And that gives you 2 into 4 plus 5. That's a 9 plus a 5, which is a 14. I believe there is no problem in this. You understand now? So in this part here, just the same context, s approaching 2 from the left. This is 2 plus 5. That's 8 8 plus this should have been 13, not 14. You understand? 2 times 4 is 8. 8 plus 5 is 13. So now shall we find the limit as s approaches 2 from both sides? If x is approaching 2 from both sides, so the limit of x approach 2 from both sides will be the same as 13 here. You understand now? Will be the same as what value we are having here. So then shall we find the value of my f of 2? My f of 2 will be, this is a very simple condition. What will be my f of 2? My f of 2 will be automatically, my f of 2 is going to give me, is going to be, look at it now, which values, this is, I think there is a 2 in this interval, isn't it? So my f of 2 is going to be 2 into 2 squared plus 5, which we have done before, which gives us 13 in one sense too. I hope you understand it now. These are questions you need to understand. I just told you this one means limit of s approach 2 from the left. This one limit of x approach 2 from the right. This one limit of x approach 2 from both sides. And this one f of 2. You understand? The only time where the limit of f, the limit where s approach 2 from both sides exists is when the value of my limit of x approach 2 from the left and 2 from the right is the same thing. If they are not the same, then the limit of f of 2, the limit where s approach 2 from the right and left, does not exist. Don't worry, I will show you an example now. Let me quickly solve another one. Let me give another question. Let me say the limit of s approach 4 from the left. Now what will be the limit of x approach 4 from the left? Look at it here. X is a number that is less than 4. You understand now? So limit of x approach 4 from the left, we have something like this is 4. Approaching 4, we have 3 point something. And 3 point something falls in this range here. So automatically the function, which is a 2x squared plus 5, gives us 2 into, substitute your 4 into it. And that gives you 2 in 16, 2 open bracket 16 plus 5. That's a 32 plus a 5, and that's a 37. Are you with me now? So what if I'm asked to find the limit of x approach 4 from the right of f of x? Yes, this one is read s limit of s approach 4 from the left. Are you with me now? So the limit of x approach 4 from the right would then be, now look at it. So we want to find the limit as s approaches 4 from the right in this case now. So what will be the limit as s approaches 4 from the right? S approaching 4 from the right include number greater than 4. You understand now? That's a number as s is, look at the region now. This is 4. Numbers approaching 4 from the right include 4.1, 0.2, 0.3, 0.4, and so on. So, and in that region, we are going to see those values in this region here. You understand now? So that means I'll pick this very function, s cubed minus 5x plus 3. And substitute x to be 4 there. You have 4 cubed minus 5 into 4 plus 3. So that's 64 minus 20 plus 3. 64 minus 20 is 44. So the value of the limit as s approaches 4 from the right is going to be 44 plus 3, which is a 47. And what's the value of limit as s approach 4 from both sides of that same function? So what will be the limit of this function here? So remember, look at the values. The value of x as s approach, the limit as s approach 4 from the left is not the same thing as the limit as s approach 4 from the right. Since their limits are not the same thing, then the value as s approaches 4 from both sides does not exist. I've told you something like this before. So that is the problem too. That's the solution to this problem. Now shall we consider this problem here? So we are going to find, let's just predict question. Find the limit as s approaches 1 from the left. So the limit as s approach 1 from the left would then be what? So values approaching 1 from the left include 0.999, 0.999, 0.89, and so on and so forth. So which values, you can see that the values approaching as s approach 1 from the left correspond to these values here. Number less than 1 includes 0.999, 0.8, like I have said now. So that means the function we are going to consider this very function here and insert 1 into that function. so that we have a 2. So shall we find the limit as s approaches 1 from the right? So the limit as s approach 1 from the right will be 7, will be, look at it now, values approaching 1 from the right include 1.1, 1.2. Now where's the range? I think it falls in this range here. This one says x, 1 is less than x. You understand? That means s is greater than 1. Number greater than 1, 1.1, 1.2, like I've said. So that means that value falls. You can't use this. You can't use that one simply because in this region x is exactly 1. So that means we are going to consider this very function here. So that you insert x to be 1, so that you have 2. So can you then tell me what will be the limit of x approach 1 from both sides? It's going to be 2, because the limit of s approach 1 from the left is equal to the limit of s approach 1 from the right. Since it exists, since it's the same thing, then the limit of this one exists. You understand now? So can we then find our f of 1? We can already find our we can find f of 4 here too. You understand now? My f of 4 will be in this region now. As you can see here, f of 4 in this case, you can find your f of 4 in this problem here. So my f of 4 will be exactly, so which point gets me an f of 4? A point where x is going to be 4. I think this region x is 4 in this region here, because number greater or equal to 4 is included. So that means we can use this value to obtain our f of 4. So you insert anywhere you see s, put 4 there, and you'll get your so-called answer. We have discussed something like that, 47. So look at this. Our f of 1 is going to be what? So as you can see here, we already have a value for x equals to 1, which is 5 in question here. So the next thing, I believe we have been able to solve as many problems as we can. So shall we take this last question now? Yes, let's take the last question quickly. Now, the last question says f of x is cx plus 3, 3x plus c, x less than 2, x greater than or equal to 2. So the question is, what value of c will make x continuous? What value of c will make s continuous, or will make the function, let me use function, continuous at x is equals to 2? Solution. Now I must tell you something, that for the value for this function to be a continuous function at s is equals to 2, then their y values must be the same thing. That is, the y value in the first equation in this must be equal to the y value in the second equation, in the sense that my cx plus 3 must be the same thing as my 3x plus c. That's the equation in this. This equation must be equal to this. Now remember, at x is equals to 2 now, we are going to substitute anywhere we see x with 2. C into 2 plus 3 is equals to 3 into 2 plus c. And that gives us 2c plus 3 is equals to 6 plus c. So we collect like terms. 2c minus c is 6 minus 3. So that c is going to be 3. So the values of c that will make the function continuous at s equals to is 3. So please don't forget to like, share and subscribe. I await your responses. You understand? I'm waiting for questions, as many questions as I can attend to. You understand? God bless you as you watch. Thank you for watching. I love you.